Now, after having studied the vector p, which we have written as ax in I direction, ay in j direction, and az in k direction, which is the xyz direction, how do we write this as a vector in matrix form? In matrix form, we can write this vector as simply a vector p, which is having three values or three rows having values ax, ay, az. Now this is the representation of the vector in space where ax, ay, az can be in meters or centimeters. But generally, we always have something that is called as a scaling factor. The scaling factor always helps us to scale up the whole operation. Let the scaling factor be W. What is the help of this? What is the good thing about this W is, suppose if we write a program or a set of matrices for a workspace which is small in size and we want to scale it up. That means we want to make it into a big workspace. That all we need to have is a scaling factor W with which we can multiply AX so that we get a value x. Similarly, we can multiply to get a value ay, multiply ay with w to get y. Similarly, we can multiply az with w, the scaling factor, to get a value of z, and then we can represent the same vector v in matrix form with the help of four values. One is, instead of ax, ay, az, we can have x, y, z, and the last value is going to be w, which is the scaling factor. Now if we have got this, the good thing is we can always find out what is the original vector by just dividing x, y, and z with w. Now if we are having w is equal to 1, we get the original size. It is the original vector without any scaling factor. So this is the original size. If we are having w is equal to 0, it means that we are only talking about direction. We are not talking about the original size of the vector. We are talking about the size to be having a value 1. That means if I am trying to find out the unit vector of p, the unit vector of p is basically vector p divided by the magnitude of p, in which I will get some value. If I take these three values and I find out, suppose if I get the value of this one as a cap, b cap, and c cap, then I will get a cap square plus b cap square plus c cap square as, and under root of that as equal to 1. That is the unit vector of p. So when we are having the w is equal to 0, we will be having the value of x, y, z in this unit vector form, where we will have the sum of the squares of the individual terms to be always equal to 1.